Okay, so as Jack said, my name is Tiarks. I am a PhD student in the School of Environment and Natural Resources at OSU. And while today we're not going to be talking directly about my research, we will be talking about something that is very near and dear to my heart, which is fish and drag. So we're going to be looking at gender bending at all different trophic levels. And more broadly, we're just going to be talking about different relationships that can exist between organisms in an ecosystem.
Better work, fish.
Oh no, the animation doesn't. Okay, whatever. So I want you to meet the star of tonight's show. This is Thalumosa bifasciatum, but we're going to call them Thal for short because I will pronounce that differently every time I say that Latin name. So we're going to go with Thal. Thal is a blue-headed wrasse, so this is a species of fish that is typically found in reef environments, and they are sexually dimorphic, which is just a fancy way of saying that the males look very different from the female wrasse. So as you can see over here up top, the males have this vibrant blue head, and then the females are this kind of yellow color. But as you may have noticed as well, Thal over here doesn't really look like either of them. So they have some stripes that are similar to the male, but then they have a little more yellow, which is more similar to a female. So for, a little fish in a big reef, that could be confusing. So Thal is going to decide to explore gender bending at different trophic levels in their ecosystem to kind of get a better idea of where they fit. So being the nerdy little fish that they are, Thal is going to draw up a food web, and they really want to see if they can find other organisms in their reef that look and act like them. So food webs consist of different organism groupings called trophic levels. So in the example of a coral reef, you have producers, consumers, and decomposers. These names are pretty intuitive. Producers are organisms that produce their own energy they produce their own energy and nutrients. Typically, this is done through photosynthesis, but especially in aquatic ecosystems, you do see a lot of chemosynthesis as well. So this is going to be your algae, your phytoplankton, your seagrasses. And then moving up the trophic level, we have consumers, which are organisms that depend on producers to get their food, energy, and nutrition. Again, there are lots of different types of consumers. You have your primary consumers, which typically eat your producers. So that's going to be your herbivores. Then you have your secondary consumers that eat your primary consumers, and so on and so forth. It is important to note that typically in ecosystems, it's not that linear. So it's not A eats B eats C. There's a lot more nuance and a lot more dynamic interactions between organisms. But for the intents and purposes of this talk, we're gonna stick with the linear relationships. So just to go over the people that Thal is going to meet on their journey tonight. So we have another primary consumer, Ham the Hamlet. Then a secondary consumer, Id the Squid. And then some tertiary consumers, Coop the Grouper and Murray the Eel. And then the apex predator, which is Sid the Shark. So the first place that Thal decides to look for gender benders is within their trophic level. So this is Thal over here on your far left, and then this is Ham, the indigo hamlet. So both blue-headed wrasse and indigo hamlets are primary consumers, which means that they feed primarily on zooplankton, different consumers or different producers, and other smaller benthic organisms. But the really cool thing about Ham, the indigo hamlet, is that they are a simultaneous hermaphrodite. So they are both simultaneously female and male. They have gonads for both, and it's that way for their entire life. And this is actually a pretty rare phenomenon in, especially in vertebrates. So now Thal decides to move up the trophic level to look for gender benders at their work. So another really cool relationship or service that blue-headed wrasse provide for their ecosystem is that they're actually really effective cleaner fish. So they form symbiotic or mutualistic relationships with other reef fish by eating ectoparasites, dead skin, debris off of larger fish in the reef. So during this cleaning, and that gives them nutrients and protection. So during this cleaning, Thal would remove parasites. So again, Thal's over here on the right. Would remove parasites from the fins and gills, as well as inside the mouth and in between the teeth. So they actually go fully inside, like the entire wrasse will be inside the mouth or completely under the gills of these larger fish. Blue-headed wrasse will also set up what are, known as cleaning stations. So they'll advertise their services by dancing and attracting customers. And then also, if a larger fish is interested, they will do a similar dance. Well, not necessarily a dance, but they will open their mouth and kind of invite other wrasse to come in and clean and send these specific signals to Thal or other wrasse. So in this image, you can see a large grouper fish being cleaned by two little wrasse over here. Groupers are also secondary consumers and have been known to eat wrasse. So it's a complicated relationship. So Coop the grouper is actually a sequential hermaphrodite, and that means that at certain points in the organism's lifetime, they can change from a male to a female or a female to a male. They actually retain both gene sets, and typically this will happen if an alpha male would die and there aren't any other males around. The most dominant female would actually then undergo a sex change and become the new dominant male. And this is really to just maintain social hierarchies and maintain social statuses within different communities. So moving right along, Thal is going to meet the Caribbean reef squid, next, which is a secondary or tertiary consumer. Similar to a lot of cephalopods, squid have the incredible ability to change their coloration, their skin pattern, even their skin texture, to match their environment or objects in their environment. So id over here is a male squid, but is not the dominant male squid within their squid school. And don't think you can see it too well, but up in the right corner, there's an image of what a squid school looks like. All those dashes are individual squids. So like I said, it isn't dominant, so he still has to kind of avoid the aggression from some of the larger, more dominant males. And to do this, he can actually camouflage himself as a female. So by changing his appearance to look like a female squid, he can actually avoid aggression from the larger squids. And this process, like a lot of things, is aptly named. So this is called sexual mimicry. And it's actually exactly what bluehead wrasse do as well. So they will perform sexual mimicry to avoid aggression from larger male fish, and also have access to better mates. But this is like quite literally a fish and drag, which just makes me so happy. Okay. So next, Thal meets moray. Moray eels are an example of a fish where both the males and the females look identical. So the sex of them is very ambiguous. Most scientists that even study these eels have a hard time determining what the sex is without doing an actual dissection. So visually speaking, moray eels have like perfected androgyny. And this is where Thal learns that there is more to an organism's sex expression than what meets the eye. So in this image here on the top, we have a female, and on the bottom we have a male. But, visually they look exactly the same. So the whole time that Thal is swimming through the reef, going on their gender bending journey, They keep coming back to the question, why gender bending? Why is this so frequent and why is it so common, especially in aquatic ecosystems? So Thal decides to ask Sid, which is the apex predator, this shark over here. No one's eating shark out in the ocean. They are the highest trophic level, and that's typical of many reef environments. So Thal asks, why gender bending, and Sid replies with all their shark wisdom that gender bending allows for population persistence. So this sexual fluidity is one of the reasons that a lot of populations can maintain numbers through sexual reproduction. It ensures that the ratio of male to female is maintained and that populations are able to continue reproducing. And maintaining healthy population actually scales up in trophic levels. It ensures that populations are around to be prey to higher trophic levels and gives rise to a lot of healthy predator-prey dynamics. A lot of times when we think of prey, we think of common species, but they're common because there's a lot of them, and they're typically eaten in large numbers by other species. So when we see widespread and abundant species supporting entire trophic levels, they can really only be abundant by ensuring that they have this population persistence. And gender bending is one of the mechanisms of doing that. So yeah, what did Thal learn from their journey through the trophic levels? Thal learned that many aquatic organisms alter their appearance and behavior. They alter their appearance and behavior to look like other sexes. They change their sex due to size, age, or social status at various points in an organism's lifetime, and that there are lots of other organisms just within this one little Caribbean reef that look and act just like Thal. Yeah, any questions?